All right, so we'll go ahead and start going over these problems that will be similar to what's on the final exam. We'll start with problem number 1, where we have a linear equation, and we're going to solve for the variable. And in this case here, we got x minus 3 divided by 3 plus x plus 5 divided by 2 is equal to 19 over 6. Okay, so so here we go, got x minus 3 divided by 3 plus x plus 5 divided by 2, and that's equal to 19 divided by 6. Okay, so here we got an equation where we got numerical terms in the denominator. So to eliminate our denominators, we need to multiply by the LCD of 3, 2, and 6. And it will be 6. Okay, because 6 is the smallest number that's divisible by 3 and by 2 and by 6 itself. So what we'll do here is multiply every single term in this equation by 6. So this will be 6 times x minus 3 over 3 plus 6 times x plus 5 divided by 2. And that's equal to 6 times 19 over 6. Okay, so here we simplify by doing this. If I divide this 3 into this 6, that would go 2 times. So here I'm going to have 2 times the quantity x minus 3 plus, and then 2 goes into 6 3 times. So this will be 3 times the quantity x plus 5. And that's equal to, and then 6, the 6's divide out, you'll be left with just 19. And then next we'll distribute the 2, well, on the left side we'll have to distribute and then combine like terms. So if I distribute that 2 over the x minus 3, I'm going to get 2x minus 6. And then if I distribute the 3 over the x plus 5, I would get plus 3x plus 15. And that's equal to 19. Now we need to combine some like terms here. So if I add 2x and 3x together, I would get 5x. And then minus 6 plus 15 will be plus 9. So I have 5x plus 9, and that's equal to 19. And now to get 5x by itself, I'm adding 9, so I need to subtract 9. So I get 5x is equal to 10. And then to solve for x, I'm multiplying by 5, so I need to divide both sides by 5. So here x is equal to 2. Now, of course, if you want to, and if you have the time, you can check that proposed solution. You'll see that the left side does equal to the right side. So x equals 2 is the solution to that linear equation with fractions. Okay. Are there any questions about problem number 1? All right, problem number 2 says to solve using the quadratic formula. Okay, so make sure that you do follow the directions on how to solve these particular quadratic equations. So in number 2, you got x squared minus 2x plus 17. And that's equal to 0. And you're told to solve that equation using the quadratic formula. Okay. So here we need to identify, and by the way, as you can see, that quadratic equation is in standard form, meaning that there is a 0 on one side of this equation. So we can identify the A, the B, and the C. Your A is the coefficient of your x squared term. That's in this case the understood 1. The B is the coefficient of x, -2. The constant term, which is going to be C. That's 17. And then the quadratic formula, that's this, x equal -b plus or minus the square root of b squared minus 4ac. And that whole thing is divided by 2 times a. And then next we'll just substitute the a, the b, and the c in that quadratic formula. So bring down x equal to, bring this negative sign down and replace the b with -2. So we have negative of -2 plus or minus the square root of b, again that's -2. So I have -2 squared minus 4 times a, which is 1, times c, which is 17. And all of this will be divided by 2 times a, which is 1. So I have 2 times 1 in the denominator. And from here we just simplify. Negative of -2 will be 2, plus or minus the square root of. If I square -2, I will get 4. And then minus 4 times 1 will be 4. 4 times 17 would be 68. Now that's divided by 2 times 1, which is 2. And then we simplify what's underneath that square root symbol. So I have 2 plus or minus the square root of. 4 minus 68 would be -64. And that whole thing is divided by 2. Now, 2 plus or minus, what's the square root of -64? 8i. Keep in mind, there is a negative sign underneath the square root, so that means -1 is underneath there. So if you take the square root of -1, you're going to get I. So the square root of -64 will be 8i. So I have 2 plus or minus 8i divided by 2. And what I'm going to do is just break this up as 2 divided by 2, and then plus or minus 8i divided by 2. So here 2 divided by 2 is 1, plus or minus 8i divided by 2, 4i. And you can leave your answer just like this, as 1 plus or minus 4i. Or if you want to, you can write it as 2 separate answers. 1 plus 4i and 1 minus 4i. Okay. Any questions about problem number 2? Now problem number 3, you're told to solve the equation by factoring. You're to solve by factoring. So in this case here we got x cubed minus 14x squared plus 48x equal to 0. X cubed minus 14x squared plus 48x equal to 0. And you're asked to solve that equation by factoring. All right, so here's what we have here. In this case here, you want to find a common factor that's in x cubed minus 14x squared and plus 48x. What would that be? It'd just be x. So we first factor out the x, and then to get what's inside the parentheses, we divide each and every term by that common factor of x. So x cubed divided by x will be x squared, and then minus 14x squared divided by x will be 14x, plus 48x divided by x. That'd be 48. So I have x times the quantity x squared minus 14x plus 48 equal to 0. Now the next step would be to go ahead and factor this quadratic expression. So I'm going to bring down the x, and I'm going to try to factor this into two binomials here. So here x squared breaks up as x times x, and then I need to find out what factors of 48 will give me negative 14x as a middle term. Okay. Well, the middle terms are minus and the last terms are plus, so they both have to be minus. So what factors of 48 gives me 14x as a middle term? 6 and 8. And they both have to be minus, so the x times the quantity x minus 6 times the quantity x minus 8 equal to 0. And then the next step would be to set each factor equal to 0 and solve for x using that zero product principle. So in this case here, I'll set the x to be equal to 0, and then set x minus 6 to be equal to 0, and then set x minus 8 to be equal to 0. And then for each equation, we'll solve for x. Well, here x equals 0 is already solved for x, but for the x minus 6 is equal to 0, x has to be equal to what? 6. And then for the x minus 8 equal to 0, what must x have to be equal to? 8. So we can consider these x values as zeros of this polynomial function. 0, 6, and 8. X equals 0, x equals 6, and x equals 8. Those are the zeros of that polynomial function. Are there any questions about problem number 3? Now, problem number 4 deals with a radical function, and this is the one you have to check your proposed solution on. Okay. Yeah, this is the one you'll have to check your proposed solution. Here we got the square root of 5x plus 14 is equal to x. And we want to solve this radical equation. Well, notice we already had the square root by itself. We have the square root by itself. So what would be the opposite of taking the square root? Squaring. So we're going to square both sides of this equation. Okay. So when you square both sides, what's happening here is that this radical, that square root, will be eliminated. And you'll be left with what's underneath it. So you'll have 5x plus 14 is equal to x squared. And then we have a quadratic equation. That means I need to get a 0 on one side of this equation. What I'm going to do is move the 5x plus 14 over to the opposite side. So here I'm going to subtract 5x on both sides. And then I'm going to also subtract 14 on both sides, because I need to get a 0 on one side. Okay, so the left side will be 0, and that's going to be equal to x squared minus 5x minus 14. Okay, So now I have a 0 on one side. I can go ahead and factor this quadratic expression into two binomials. So x squared breaks up as x and x. Now I need factors of a negative 14 that will give me minus 5x as a middle term. What would that be? 7 and 2. Now which one would be negative and which one would be plus? The 7. Okay, because the larger the two factors will take that sign of the middle term. Because the middle term is minus, so that means the 7 has to be minus. So here I got x minus 7 times x plus 2 equal to 0. And then we set each binomial factor equal to 0. So this means x minus 7 is equal to 0, or x plus 2 equals 0. And then for each equation, we'll solve for x. So for the x minus 7 equal to 0, x has to be equal to what? 7. And then for the x plus 2 equals 0, x must be equal to what? Negative 2. So these are my two proposed solutions, x equals 7 or x equal negative 2. Now, this is where you have to check your proposed solutions on each one of those to see which one satisfies the original equation. And I'll start with x equals 7. So using the original equation I started off with, I'll replace each x with 7. So I have the square root of 5 times 7 plus 14, and that's equal to x, which is 7. Now here I'm going to simplify the left-hand side. Here 5 times 7 would be 35, so I have the square root of 35 plus 14. This should equal to 7. And then 35 plus 14 would be 49. So I have the square root of 49. That should equal to 7. If I take the square root of 49, it's 7. So in this case here, 7 does equal to 7. That checks. So that tells me that x equals 7 is the solution to that radical equation. And I'll go ahead and do x equal negative 2, just to verify that it's not a solution here. Should be plus 14. So here I'm replacing every x with negative 2, so I have the square root of 5 times negative 2 plus 14 is equal to negative 2. Now 5 times negative 2 is negative 10, so I have the square root of negative 10 plus 14 should be equal to 2. Negative 10 plus 14 will be 4. And if I take the square root of 4, that's a positive 2. And that does not equal to negative 2, so that's a false statement. So x equals negative 2 is what we call our extraneous solution for this radical equation. So that means x equals 7 is the solution to that radical equation. All right, questions on problem number 4. Okay. All right, now problem number 5 deals with a absolute value equation. And here we got 3 times the absolute value of 2x minus 5, and then plus 4 is equal to 25. And here we want to solve this absolute value equation. Well, the first thing we need to do here is get that absolute value of 2x minus 5 by itself. Okay, so I need to move that plus 4 over to the other side. And that's by subtracting 4 on both sides. So here we got 3 times the absolute value of 2x minus 5. And that's equal to 25 minus 4. That's 21. But I still got to get the absolute value of 2x minus 5 by itself. We're multiplying it by 3, so I need to divide both sides by 3. So here I got the absolute value of 2x minus 5, and that's equal to 7. Now that I have the absolute value symbol by itself, I can go ahead and write my 2 separate equations. Okay? So with absolute value equations, we write them as 2 separate equations. One of them would be 2x minus 5 equals to positive 7, or 2x minus 5 equals to the opposite of 7, which is negative 7. All right, and then for each equation, you'll solve for x. So for the 2x minus 5 is equal to 7. If we add 5, you'll get 2x is equal to 12. Then divide both sides by 2. X is equal to 12 divided by 2 is 6. And then the or, for the second equation, we got 2x minus 5 equal negative 7. So we add 5 to both sides. Here we got 2x is equal to negative 7 plus 5 will be negative 2. And then divide both sides by negative 2, you'll get x is equal to negative 1. So that means here x equals 6 or x equals negative 1. Those will be your 2 solutions for this absolute value equation. Now these don't require the check. Okay. Are there any questions about problem number 5? Now, in number 6, we have an inequality that we're going to solve. So here we got 7 times the quantity x minus 8, and then plus 3 on the outside is less than 6 times the quantity x minus 5 plus 3x. And here we're going to solve this inequality just to get x by itself. So in this case here, we have to distribute the 7 over the x minus 8. And what will we get for that? Well, 7 times x is 7x, minus 7 times 8, 56. And then bring down the plus 3 is less than. Distribute the 6 over the x minus 5. 6 times x, that's 6x, minus 6 times 5, that's 30. Then plus 3x. And then on each side of this inequality, we'll combine like terms. Let's see here. Bring this 7x down. If I add negative 56 to 3, I would get minus 53. So it'll be 7x minus 53 on the left side. And it's less than 6x and 3x will give me 9x minus 30. All right, now we need to get the variables on one side of the equation and the constant terms on the other side. It would be best to move the variable on the left-hand side since we're dealing with an inequality. So I'm going to move the 9x over to where 7x is by subtracting 9x on both sides. So here I got 7x minus 9x. That's going to give me negative 2x. Minus 53 is less than And make sure you bring that negative sign in front of the 30, so it'll be negative 30. And now to get negative 2x by itself, I'm subtracting 53. I need to add 53. All right, so we got negative 2x is less than, what's negative 30 plus 53? Just 23. So I get negative 2x is less than 23. Now, when I divide both sides of an inequality by, in this case, negative 2, what's going to happen to that less than symbol? We're going to flip it from less than to greater than. And I will leave this as negative 23 over 2. I'll leave that as an improper fraction. Okay. So x is greater than negative 23 over 2 would be the solution set for this inequality. All right, questions about problem number 6. All right, problem number 7. Here we got an absolute value inequality here. Here we got the absolute value of 2x plus 13 is greater than 7. All right, notice we do have the absolute value by itself. And take a look at your inequality symbol. That inequality symbol will tell you how to write your inequality. If it's a less than, that means you have to write it as a compound inequality. If it's greater than, like this one here, we write this as two separate inequalities. And in this case, that's what we're going to need to do. Write this as two separate inequalities. One of them would be 2x plus 13 is greater than 7. Or the second one will be 2x plus 13. But this time, our inequality symbol changes from greater than to less than. That 7 changes to the opposite, negative 7. And then we're going to solve each inequality. So starting with the 2x plus 13 is greater than 7. Well, if I subtract 13 on both sides, so here we got 2x is greater than 7 minus 13 would be negative 6. So I got 2x is greater than negative 6. And then divide both sides by 2, you'll get x is greater than, let's see, negative 3. And then for the other inequality, 2x plus 13 is less than negative 7. Well, I'll still subtract 13 on both sides. But this time, 2x is less than negative 7 minus 13 would be negative 20. And divide both sides by 2, x is less than negative 10. So we just leave that as is. X is greater than negative 3 or x is less than negative 10. Here we divide by a positive number. So the signs stay the same. In number 6, I had to flip the sign because I divided both sides of an inequality by a negative number. Yeah. If the negative sign is in the denominator and you're dividing, you have to flip the sign. In this case, I was dividing both sides of an inequality by a positive number, so the sign remains the same. Any other questions? All right, problem number 8. Here you're given three different mappings, and you want to select the graph of a relation which is not a function. You want to select the one that is not one-to-one and the one that is one-to-one. All right. So in this case here, let me just write A, B, and C. Let's start with the one that is not a function. Here you want to pick the mapping where you got, and let's say this is x and that's y, where you got an x value going to two different y values. When you have that, it is not a function. So which one of these, A, B, or C, is not a function? Is B. Here's x and that's y. You got one going to two different y values, 5 and 11. So mapping B is not a function. Okay. So we're left with A and C. Let's pick the one that is one-to-one. Is A. Okay, because for every y value, you only got one x with it. So A is considered to be one-to-one. Which means C is not one-to-one. And the reason for that is this. Notice here, you got this y value with two different x values, and we can't have that. So that means not one-to-one. All right, question about problem number 8. All right, problem number 9 deals with a piecewise function. Okay, we have a piecewise function here. So here we got f of x is equal to, and here we use the 3x plus 9. And that's only if your x value is less than 1. Or we use x squared plus 1 if the value of x that we're trying to find is greater than or equal to 1. And it says for x is equal to 5. So in other words, we're evaluating f of 5. Now based on the x value of 5, which one do we need to use? The one on the top or the one on the bottom? The one on the bottom, because 5 is greater than 1. So we have to use x squared plus 1 and replace that x with 5. So it'd be 5 squared plus 1. Well, if I square the 5, I'm going to get 25. Add 1 to the 25, you'll end up with 26. So the value of that piecewise function when x is equal to 5 will be 26. All right. Questions about problem number 9? All right, problem number 10 is finding the domain of this function. So here we got f of x is equal to 18x squared plus 123x minus 203. Divided by x squared plus 5x minus 24. All right, in this case here, Do I have a polynomial function, a rational function, or a radical function? I got a numerator and a denominator. I have a rational function. Okay? Rational functions have a numerator and a denominator. You have variables in the numerator and the denominator. So what I need to do here is take what's in that denominator, set it equal to 0, because I want to find out what values of x that will give me zeros in the denominator. So I'm going to take that x squared plus 5x minus 24 and set that equal to 0. And it is a quadratic equation, so let's try to factor x squared plus 5x minus 24 into two binomials here. Okay, so x squared breaks up as x and x. Now what factors of negative 24 would give me a middle term of 5x? 8 and 3. Which one has to be plus? The 8. Again, the larger of the two factors takes the sign of the middle term, so the 8 has to be plus, the 3 has to be minus, so I have x plus 8 times x minus 3 equal to 0. And then we set each binomial factor equal to 0 and solve for x. So x plus 8 equals 0, or x minus 3 equal to 0. And each equation will solve for x. So for that x plus 8 equal to 0, if I subtract 8, I'll get x is equal to negative 8. Or for the x minus 3 equal to 0, x must be equal to 3. So I know at x equal negative 8 and at x equal 3, I would get zeros in the denominator. And here we're finding the domain of that rational function here. Okay, and on the exam you'll be required to give your answer for the domain in interval notation. Now this is not necessary, but if this helps, let's see, negative 8 is here, 3 is to the right of 0. Now we know at negative 8 we'll get a 0 in the denominator, and at 3 we'll get a 0 in the denominator. Any x value less than negative 8 would work. Any x value in between negative 8 and 3 would work, and any x value greater than 3 would work. So our domain in interval notation from left to right, it would be from negative infinity up to negative 8, or from negative 8 to 3, or from 3 on out to infinity. All right, so that's the domain of that rational function in interval notation. Are there any questions about problem number 10? All right, number 11 on the next page deals with the algebra functions. So here we got f of x equal to 3x minus 1 and g of x equal to negative 7x plus 2. So here we're going to find the difference of the two functions, f minus g of x. And in this case, we're finding f minus g of x, which means, in this case, f of x minus g of x. F of x minus g of x. So here f of x is 3x minus 1, and then minus. Now keep in mind the entire g of x function is being subtracted from f of x. So I do need to put parentheses around negative 7x plus 2. Okay. All right, the next step would be to do this. Distribute that negative sign over the negative 7x plus 2. So the minus sign makes negative 7x plus 7x. The minus sign makes it plus 2 minus 2. And then combine like terms. 7x and 3x will give me 10x. Minus 1 and a minus 2 will give me negative 3. So the difference of the two functions f and g would be 10x minus 3. Okay. Are there any questions about number 11? All right, number 12 is the composition of two functions here. So here we got f of x is equal to 2x plus 5. And we got g of x is equal to x squared minus 7. And we're told to find the composition of f with g of x, or f circle g of x. Which simply means this, f of g of x. That means your inside function is g of x, the outside function is f of x. Okay. Now, our inside function is g of x, but g of x is x squared minus 7. So I'm going to replace that g of x with what is equal to x squared minus 7. So I'm going to be evaluating f of x squared minus 7. But of course, f of x is equal to 2x plus 5. That means for every x in the f of x function, I'm going to replace it with what g of x is. So that means in f of x, that x will be replaced with this g of x squared minus 7. And in this 2x plus 5, that x will be replaced with the g of x function, x squared minus 7. All right, and then the next step would be to go ahead and simplify the right-hand side. Well, if I distribute the 2 over the x squared minus 7, that means 2 times x squared would be 2x squared minus 2 times 7, that's going to be 14. Then bring down that plus 5. And then minus 14 plus 5 will give me minus 9. So that means here the composition of f with g of x equals 2x squared minus 9. Okay. Are there any questions about problem number 12? Now, problem number 13 is just what they call decomposing the functions. That means you're going to take that composed function and just write it as two separate functions, f of x and g of x. In this case here, you got the f of g of x, by the way, and that's equal to is equal to 5 divided by x squared minus 3x plus 6. And that quantity is raised to the 6th power. So here we want to find out what f of x started off as and what g of x started off as. Well, let's start with the g of x, which is your inside function, by the way. All right, what I would do here is this. What's inside the parentheses here? That x squared minus 3x plus 6. I will let that be g of x. That would be g of x here. So here, g of x would be that x squared minus 3x plus 6. And as for f of x, since that x squared minus 3x plus 6 was put in place of x in the f of x function, my f of x function had to start off as 5 divided by x raised to that power of 6. So f of x started off as 5 divided by x minus 6, and g of x is equal to x squared minus 3x plus 6. Okay, and that's all there is to it. Are there any questions about problem number 13? All right, problem number 14 deals with finding the inverse of a given function. And in this case, we got f of x is equal to 2x plus 6. Sorry, 2x minus 6. F of x equal 2x minus 6. And here we're going to find f inverse of x. Now, the way we find the inverse, there was a 4-step procedure that it gave you to find that inverse of a function. Number 1, you replace your f of x notation with y. So it'd be y is equal to 2x minus 6. The next step would be to interchange those two variables, x and y. So that means that this y becomes x. That's equal to 2 times the x becomes y. So the x equals 2y minus 6. And then step number 3 is to solve this equation for y. So what would be the first thing I need to do here to get y by itself? Add 6. So that means I have x plus 6 is equal to 2y. And then what's next to get y by itself? Divide both sides of that equation by 2. So that means y is equal to x plus 6, and all that's divided by 2. And then the last step would be to replace the y with my f inverse notation. So this y would be substituted with f inverse of x. And that's equal to x plus 6, all divided by 2. So this is what f inverse of x will be. X plus 6 divided by 2. Are there any questions about problem number 14? All right, number 15 is this. We're just finding the coordinates of the vertex of the parabola defined by the quadratic function f of x is equal to 2x squared minus 12x plus 3. F of x is equal to 2x squared minus 12x plus 3. Another way we do that would be this. We need to identify the a and the b. And this is, of course, the general form for a quadratic function. The a is the coefficient of x squared. That's 2. The b is the coefficient of x. It's negative 12. Anytime you want to find the x-coordinate of the vertex, we always use x equal negative b divided by 2a. X equal negative b divided by 2a. And then substitute. I'm going to bring the negative sign over, replace the b with negative 12, so I have negative of negative 12 divided by 2 times a, which is 2. And then the opposite of negative 12 is 12. The denominator 2 times 2 will be 4, and then 12 divided by 4 is 3. So here, x equals 3, that would be the x-coordinate of the vertex. Now to find the y-coordinate of the vertex, we substitute each x in this function with the 3. So we're going to evaluate f of 3. That's equal to 2 times the quantity, 3, and that's squared, minus 12 times x, which is 3, plus 3. And then we'll just simplify all of this. Let's see, if I squared the 3, that's going to be 9. 9 times this 2 in front would be 18. Minus 12 times 3, that's 36, plus 3. Now, what's 18 minus 36 plus 3 equal to? Negative 15. Okay. So here the vertex would be this. X is 3. The y-coordinate, negative 15. So the vertex of that parabola will have the ordered pair 3, negative 15. Right. Are there any questions about problem number 15? Okay. All right, problem number 16. Let's see, here we got f of x equal to x squared plus 4x minus 5. And here we're going to sketch the graph of the parabola using those 4 steps that I have here, A, B, C, and D. So in this case here for part A, you are to find the y-intercept. Now keep in mind, anytime you're finding the y-intercept, you always let x equal 0. So that means that we substitute each x in that function with 0. So this means I have f of 0 equaling to x, which is 0, and that's squared, plus 4 times x, which is 0, minus 5. And then 0 squared, of course, that's 0. Plus 4 times 0 is 0. 0 plus 0 minus 5 would end up being negative 5. So the ordered pair 0, negative 5 will be your y-intercept. Okay, so that's part A, finding the y-intercept. Now part B says find the x-intercepts. anytime you're finding your x-intercepts, you take the function itself and set it equal to 0. So if I let f of x equal to 0, that means f of x is that x squared plus 4x minus 5. Set that equal to 0. And in this case here, it is a quadratic equation. Let's go ahead and try to factor x squared plus 4x minus 5 into two binomials here. Okay, so x squared breaks up as x and x. Now what factors of minus 5 gives me a plus 4x as a middle term? 5 and negative 1. So I have to use a plus 5 and then minus 1. So it'd be x plus 5 times x minus 1 equal to 0. And then for each, we set each binomial factor equal to 0 and solve each equation for x. So here I'm going to have x plus 5 equal to 0 or x minus 1 equal to 0. And then for each equation we'll solve for x. So for the x plus 5 equal to 0, x is equal to what? Negative 5. And then for x minus 1 equal to 0, x is equal to what? 1. Now these are two separate ordered pairs for our x-intercepts here because we're letting the function f of x equal to 0. So I have two x-intercepts here. One would be negative 5, 0, and the other one will be 1, 0. Those are my two x-intercepts. That means those are the places where the graph will be crossing the x-axis. Part C is find the coordinates of the vertex. And scratch off this part that says by completing a square. Because all you have to do there is just use the formula for the x-coordinate of the vertex. So here we're going to be finding what the vertex is. And just like we did in problem number 15, we need to identify what A is and what B is. So my A is the coefficient of the x squared term. That's the understood 1. B is the coefficient of x, which is 4. And then we use x equal negative b over 2a to get the x-coordinate of that vertex. So here I'm going to replace the b with 4. So I have negative 4 over 2 times a, which is 1. So here I got negative 4 over 2 times 1, which is 2. And negative 4 divided by 2 would be negative 2. So the x-coordinate of that vertex is negative 2. Now, of course, for the y-coordinate of the vertex, we substitute every x in that function with negative 2. So f of negative 2 would be this. That'd be negative 2, and that's squared, plus 4 times x, which is negative 2, minus 5. So if I simplify this, square that negative 2 will be 4. 4 times the negative 2 will be minus 8. And what's 4 minus 8 minus 5? Negative 9. So the vertex in this case will be the ordered pair, negative 2, negative 9. Okay. All right. So that's part C. Now part D, of course, is graphing this on a coordinate plane. And on the final exam, you will have a coordinate grid where you can graph the parabola. Okay. All right, so there's the coordinate grid. All right, so let's go ahead and plot what we already have. We do have the y-intercept of 0, -5. So that's going to be this point on the y-axis. And then I have my x-intercepts of -5, 0, which is over here on the left side, and 1, 0, which is over here. And then my vertex is -2, -9. So to the left 2 and down 9. Now I know I didn't ask for this in this problem, but it would be best to draw the axis of symmetry. And that axis of symmetry will be that vertical dotted line going through the vertex and the x-axis. Okay. Now to get an additional point, if you look at the distance from the y-intercept to the axis of symmetry, that distance is 2 places to the right. So another point on the left side will have to be 2 places to the left, because we have to be symmetric. The left side has a mirror image of the right side. Okay. So here I connect those dots. This will be the graph of that parabola. F of x equal to x squared plus 4x minus 5. Okay. Are there any questions about problem number 16? Okay. All right, problem number 17 is solving the system of equations using either substitution or elimination. All right, here we got 3x minus 4y is equal to -11, and 2x plus 3y is equal to -4. I mean, not -11, just 11. All right. Now we need to find out, well, we can't use substitution because I don't have a understood coefficient of 1 on either the x or the y, so we'll have to try elimination here. Which variable would you like to eliminate, the x or the y? Preferably, I eliminate those y's because those have opposite signs. One's a minus, the other one is a plus. Okay. But in this case here, I need a least common multiple of those coefficients for the y's, 4 and 3. What would that be? 12. All right, so for that first equation, if I want that minus 4y to be minus 12y, I need to multiply it by what number? By 3. And then for the second equation, if I want that plus 3y to be plus 12y, I need to multiply it by what number? By 4. All right, so when I do that, that first equation, multiply it by 3, you're going to get 3 times 3x, which is 9x, minus 3 times 4y will be 12y, is equal to 11 times 3, which is be 33. And then 4 times 2x, that's 8x, this is for the second equation. And then plus 4 times 3y, which is 12y, is equal to 4 times -4, that's -16. Now we can add these two equations together. Add 9x and 8x, you're going to get 17x. And then, of course, that minus 12y and the plus 12y add to 0. That's gone. So I have 17x equal to 33 plus negative 16. That's 17. So I have 17x equals 17. And now I can solve for x by dividing both sides of this equation by 17. That means x has to be equal to 1. And since x is equal to 1, I can find out what y is by using one of the two original equations and just replace that x with the 1. So I'm going to use that second equation. 2x plus 3y is equal to negative 4. If you wanted to, you could use that first equation if you wanted to. Replace the x with 1, so it'll be 2 times x, which is 1, plus 3y equals negative 4. And then 2 times 1 would be 2. So it'll be 2 plus 3y is equal to negative 4. And then to get 3y by itself, we're subtracting 2 on both sides. So now 3y is equal to negative 4 minus 2 will be negative 6. Divide both sides of the equation by 3, you'll get y is equal to negative 2. So in this case here, the solution for this system of equations would be the ordered pair 1, negative 2. Okay. Are there any questions about problem number 17? All right, problem number 18 is using Cramer's rule to solve the system of equations. And we did talk about determinants in Cramer's rule before fall break. So here we got 4x plus 3y is equal to 15. The second equation, 2x minus 5y is equal to 1. All right, so in this case here, we need to have 3 determinants. One for d. The second one is for d sub x. And the third one is for d sub y. All right. Now, of course, if you recall, for your d, it's just going to be your x and y coefficients. For d sub x, instead of the x coefficients, you'll have your constants in the first column, and then your y coefficients in the second column. Then for d sub y, you'll have your x coefficients in the first column, but your constants will be in the second column. And of course, they are in standard form. Those equations are in standard form. So your x coefficients are going to be in this order: 4 and then 2. And then for the y coefficients, 3, then negative 5. And then for d sub x, instead of the x coefficients, you'll put in your constant terms in place of them, the 15 and then the 1. And then the y's would be 3, negative 5. Now for the d sub y, your x coefficients in the first column would still be 4 and 2, but your constant terms would be in place of your y's, 15, 1. Okay? Now we're going to find the determinants for each one of these. So starting with the d, the determinant of your denominator, 4 times negative 5, that's negative 20, minus 2 times 3, that's 6. Negative 20 minus 6 is how much? That'd be negative 26. And then for the d sub x is this. 5 times negative 15, that's negative 75, minus 3 times 1. That's going to be 3. Negative 75 minus 3 will be negative, 78. And then d sub y finally will be this. 4 times 1 will be 4, minus 2 times 15, that's going to be 30. 4 minus 30 would be negative 26. So I have d sub x, and d sub y. I'll use those to find out what x and y are going to be. So here x is always d sub x divided by d. D sub x, that's negative 78, divided by the d in the denominator, that's 26. Negative 78 divided by negative 26 ends up giving me 3. And then for the y, that's d sub y divided by d. D sub y, that's negative 26, divided by d, that's negative 26. Negative 26 divided by negative 26 is 1. So I have x and y solved. So the solution for this system of equations would be the ordered pair 3, 1. Okay. Are there any questions about problem number 18, using Cramer's rule to solve a system of equations? All right, problem number 19 is evaluating that 3 by 3 matrix, or finding the determinant of the 3 by 3 matrix. So here we got 3, 2, negative 1, 2, negative 2, 4, 5, and then 1, 3, 1. Okay. So here I want to find the determinant of that 3 by 3 matrix here. So the first thing we do here is rewrite the first 2 columns of that matrix here. That's going to be the 3, 2, negative 1, then negative 2, 4, 5. Now, of course, to find the determinant of that 3 by 3 matrix, we take the product of the first 3 diagonals going in this direction, or the sum of the products of the 3 diagonals going in this direction, from the upper left to the lower right. Okay? So that means I do 3 times 4 times 1. Well, 3 times 4, that's 12. 12 times 1 is 12. And then plus the product of the next diagonal going in this direction. Negative 2 times 3, that's negative 6. Negative 6 times negative 1 is 6. And then plus the product of the next diagonal here, 1, 2, and 5. 1 times 2, that's going to be 2. 2 times 5 is 10. And then we're going to subtract each product of each diagonal going in this direction, from the lower left to the upper right. So I know I'm going to have a minus whatever the product of this diagonal is. Negative 1 times 4, that's going to be negative 4. Negative 4 times 1 would be negative 4, so I'm going to have a minus negative 4. And then minus the product of this diagonal, 5, 3, and 3. 5 times 3 will be 15. 15 times 3 will be 45. And then minus the product of this diagonal, 1, 2, and negative 2. 1 times 2 will be 2. 2 times negative 2 will be negative 4. Okay. Now, if you want to, you can write it like this, like 12 plus 6 plus 10. Minus a negative 4 will be plus 4, then minus 45. And again, minus the negative 4 would be plus 4. So if you were to add 12 plus 6 plus 10 plus 4 minus 45 plus 4, you'll end up with negative 9. So the determinant of that 3 by 3 matrix ends up being negative 9. Okay? Any questions about problem number 19? Okay. Let me quickly do number 20, and that will do it for today. The rest I will finish up on Thursday. Because that's the one we just used to change of base property. Log to the base 3 of 17. And we round to 2 decimal places or to the nearest hundred. So what that means here is this: when we use the change of base property, we can use either common logarithms or natural logarithms in this case. So here I have the log of the number itself, that's 17, divided by the log of that base, which is 3. So here I'm taking the common logarithm in the numerator and the denominator. So, in the calculator, we press the log key and then type in number 17, close your parentheses, divided by, press the log key again, and then 3, close parentheses, and then hit enter. So the 2 decimal places, this will be approximately 2.58. So log to the base 3 of 17 would be approximately 2.58. Are there any questions about problem number 20?